Hello, my name's Brian, and this is Kevin.
Hey.
And this is Introduction to Programming Languages. This will be a relatively fast-paced introduction to basic concepts of programming languages, development concepts, and what you'll generally get exposed to when starting to program.
We're going to just kind of take this from a high level at first, and then as these videos go along, we're going to kind of get a little bit deeper and deeper into the actual gears and switches of this whole thing. The first piece that we want to discuss are the core instructions. What can my computer do for me? It's easy in today's computing world to forget that we see all these wonderful, fun graphics and sounds, but computers really only have very basic things that they actually do. And it's just the manipulation of these things that produce these things that we see and use all the time.
Mm-hmm. Everything that your computer does is essentially based on a series of execution statements of basic math and moving data around and in basic comparison operations. Basic math is just addition, subtraction, multiplication, division. When memory is moved, like a file is copied or loaded into memory, or it's basically just storing and moving data.
So in the process of loading a file, you're storing small pieces of data in the memory registers to walk it through.
Bitwise operations, something and something else, or something or something else.
Yeah, we get to that later, but bitwise operations are just basically logical expressions.
Comparisons, if something is greater than or less than or equivalent to or not equal to, and control flows. So if this happens, then do this. Or once you get to this point in the program, jump over to another point in the program.
Or execute this code while this condition is true, which is the concept of a loop.
So these are the basic things a computer can do. So when you watch a movie on your computer, when you watch a Facebook page of somebody telling you that they made a sandwich a minute ago, those are all based on basic math, basic logic. It's just a very complex combination of those very basic functions.
Yep, and all these fun things that we see are just built on top of this. Brian and I also wanted to discuss the two fundamental types of languages. We want to discuss the low and high level languages. The low level languages, even within these, there are subsets. But generally speaking, a low level language is some sort of language that has little to no abstraction from the machine architecture.
It's not human readable. It looks like matrix code. Like it looks like something that you'd really have to get into and really focus on to understand. So it's not necessarily designed to be convenient for people to use, but it is designed to be efficient and relevant for the computer to understand.
Right. It also, low-level languages also technically fall into the machine and switch realm, whereas even before languages existed, all people did was manipulated wires and switches to perform an instruction.
Believe it or not, low-level languages were originally used to be convenient for people, but that was kind of the best that they had, you know. So now we're used to very fluffy languages like Java, but back when computers started, they were just getting us going. But there's also high-level languages, languages with greater abstraction, more human-readable, and the way that the language reads is kind of the way you describe the program. If this happens, then do this while this is happening. It's more of a sentence structure.
So if you kind of also look at this slide, we mentioned that there are language generations. We wanted to kind of put this here without explaining it, but in just 1 second, actually right now, we will take a look at the language generations. Like I was kind of just describing a minute ago about the machine level languages, the low level languages, they kind of sit within these first and second generation, and they kind of bleed into each other. In the first generation of languages, this is around the time that digital computers were becoming in full use. From the 1930s to about the 1950s, you were seeing a lot of things that were vendor-specific types of instructions that were either manipulating cables or switches, or machine code such as binary or assembly language in order to get a computer to do something. And these were the days where you had to have thick glasses, a pocket protector, and no life in order to work on these machines.
And debugging actually means like killing bugs and cleaning them out of the system, like actual insects. So second generation is not far from that, but there is a little abstraction from the machine language. And we start seeing this in the 1950s, the 1960s, where you start having some more wide applications of the same systems. So like you were saying, they're more vendor-specific. As machine abstraction began, you could use the same system and apply it in a few different ways.
Right. Also kind of making things a little more industry standard. That kind of started around this time.
Absolutely. So this is where we first start seeing logical operations, and this introduces languages like Fortran, Lisp, COBOL.
In the next couple generations, and actually before we continue, we want to mention that if you look up language generations, you may not see it exactly laid out the way Brian and I did it. We kind of did it the way that we felt that it should be, and not necessarily the way that some people have designated this to be. Because Brian and I were actually kind of heartbroken that so many people believed that modern framework languages belonged in the third generation, when there's an obvious distinction between third generation and modern languages now. When we talk about third generation languages, languages, we talk about the move towards human-friendly languages, in which we started seeing that around the 60s into the 80s, which we saw a much more further abstraction from the structured languages that we were talking about before, like Fortran and COBOL. The momentum was to try to make it so that humans could actually look at a piece of source code and understand what it's doing just by looking at it. We also saw things like the introduction of abstract data types and object-oriented programming, and some of the languages around this time that were coming out was Smalltalk, which was credited as the first object-oriented language, and then your lower languages like C, which is a low, high-level language, if that makes sense. C++, BASIC, and SQL.
Fourth generation languages are where we start seeing frameworks. Not only are they human-friendly and have a very natural speaking flow to the language, but they're also utilize large libraries to perform some of the more complicated functions. So in the fourth generation languages, you will not be so tempted to have to write your own sorting algorithm or your own hash table, like how to do certain types of things. They're all kind of done for you. If you want to open a socket, you just say, I want to open a socket. So instead of having to have your own arsenal of things that you bring into your program or rewrite how sockets operate every time, you just kind of speak at a more higher level, I want the computer to do this. Instead of, I want this action to happen.
And this is based a lot on application frameworks, like Brian was saying, like this collection of classes. So when you actually run software, it runs on top of another layer where all this stuff is defined. You also see from this the Java realm and that sort of thing, where your code is actually running in like a virtual environment. So you have like a program that the code runs through, and that's what it executes on. Some examples of these generation is Visual Basic, C#, Java, and Ruby.